Hello and welcome. Today we will learn Part C July 2024 some of the questions. I am Asra Nazneen from S.D.V.Academy. Given, let a n be the convergent series of a real number here. For n is greater than or equals to 1. Defined. So this is the value of a n and this is the value of b n which has been given here. As a n tends to 0, b n tends to 0 as n tends to infinity here. So consider here when you apply the limit of n tends to infinity, this a n value will becomes 0. Consider here a n that equals to 1 by n here. When you apply the limit of a n, okay, to find the value of a n here, as n tends to infinity, this value becomes 0 here. So this value is 0. That implies bn will also becomes 0 as n tends to infinity. Consider bn is also minus 1 by n here. So as n tends to infinity, this value is also becomes 0 here. So these two options are correct here. For checking the absolute convergent value, we have to check mod of an. This value is absolute convergent. Okay, so this a n value is also convergent here. That implies a n sigma a n. This value is also absolute convergent here. So when bn value is also absolute convergent here, that means when a n and convergent, bn and absolute convergent means both are absolute convergent. This statement is also true here. Now for checking the option C here, consider the series minus 1 whole power n by n. This value is convergent. Okay, now a n value will becomes 1 by n and b n value becomes minus 1 by n here. This value is divergent and this value is divergent. When you apply the limit, it becomes the same limit, but when you check the convergence here by p test, this value is divergent here. So these both are convergent. This is not the true statement here. This is the false statement. When an is not absolute convergent, then both are divergent here. For checking this, take the previous example only, minus 1 whole power n by n here. So by p test, these both are divergent. An and bn both are divergent here. Okay, when these two are divergent here means when it is a not absolute convergent. This is the perfect example to test the convergency. When this an is not absolute convergent means minus 1 whole power n here means an is greater than 0 by n. By p test, this is divergent here, and minus 1 by n by p test, this is also a divergent here. When these two are divergent here means this is the correct option here. So this is the wrong option and these three are the correct option here. Consider this is the function. So f of x is equals to x mod x. Which of the following is true? We have to prove here. Consider this. What is the value of f of x here? Becomes here x square when x is greater than 0, 0 when x equals to 0, and minus x square when x is less than 0. These are the values that has been formed here. Now consider what are the graphs that will form here. This is the x square graph and this is the minus x square graph. Okay, minus x square graph here. So these graphs are continuous graphs, so f is continuous. That is true here. F of x is equals to x square. This is the polynomial that has been formed here. So when x is greater than 0, that implies f of x equals to x square, that is polynomial. Okay, now when x is less than 0, f of x equals to minus x square. Okay, this is also a polynomial here. Okay, now to check the differentiability, limit x tends to 0, f of x minus f of 0 by x minus 0 here. So this value becomes limit x tends to 0 minus means minus of x square minus 0 by x. This value becomes minus x. When you apply the limit here, this value becomes 0 here. So it is differentiable. Now consider the limit x tends to 0 positive here. So f of x minus f of 0 by x minus 0, that equals to limit x tends to 0 plus x minus 0, x square minus 0 by x here. So limit x tends to 0 plus of x gives the value here 0 here. So this is differentiable only at 0 and differentiable on real numbers, and f is continuous on real numbers. These are the correct option here. Not differentiable, this is the wrong statement here.